Hello students. Today I am going to explain about full wave rectification as third video of electronic lesson. Let's start. In previous video, you learned about half wave rectification. In this video, you can learn about full wave rectification. You can see bridge rectifier in this screen. It has 4 diodes within special arrangement. Then you must keep in mind how to arrange these 4 diodes. Let me connect an alternator into this circuit. Alternator will generate alternating current. It may be dynamo or transformer output, and let me connect or keep in mind this input side into this bridge rectifier. Okay, you can keep in mind these positions top and down. Then next I will connect a resistive load into this circuit. Let me show you another experiment. You can see this screen. There are 2 circuits. In first circuit, this battery connected to a DC motor. But other circuit, there is a motor, but DC battery has changed. Then what will happen when I run this program? When we change battery side, the motor rotating side has changed. I will use previous observation to explain another thing. You can see 3 devices in this screen. I will connect this DC motor into this bridge rectifier. You can keep in mind this output side, and let me connect battery into this bridge circuit. This is input side, keep in mind. Then I will run this program. You can see motor is rotating into clockwise direction. I will mark it like this. Okay, motor is rotating into clockwise direction. Then I want to change direction of this battery. Then what will happen? According to previous observation, the battery rotating side should be changed. Then let me change it. I change out this battery side. Then let's run this program. What happened? The rotating direction not in change. What is the conclusion you can make by this observation? When we change this battery side, the output voltage will not change. Current flow in direction not will change. Then what will happen when I replace an alternator into that battery pack? Let me run this. Then input side has alternating voltage, but output side has direct voltage. Now you have confirmed that which rectifier can be used to correct direction change of alternating current. If you use center tap transformer to make this experiment, you can see same effect. Okay, let me construct this circuit. I use center tap transformer. In this case, you can see we use only 2 diodes. In previous case, we used 4 diodes in bridge rectifier, but in this case we used only 2 diodes. But you must use center tap transformer for this circuit. You can see motor is rotating into clockwise without any changing. Now you have confirmed 2 diodes within center tap transformer can be used for rectification. I think you will like to see output waveforms from these 2 circuits, such that bridge rectifier circuits as well as center tap transformer outputs. Okay, let's see. As first, let me show you output waveforms from bridge rectifier circuit. I will connect an oscillator into this output side, and also I will connect from input side. Then you can compare these 2 type of waveforms. Okay, let me run this. Now you can see this screen. This yellow graph represent input waveform, and this pink color waveform represent output waveform. Let me show you another type of graphs. These are current graph respect to time. Then I will show you input side, input current wave. You can see it is an alternating current wave, as you know. Let me show output side. You can see difference of this graph. They don't confuse with these values. Sometime you will confuse with this amplitude. These amplitudes are same. Then you can confirm it within this y value. y-axis, you can take that values from y-axis. In previous case, that half wave rectification, you saw there one part of wave was cancelled out, but in this case full wave has used for rectification. You will see same type of graphs when you use center tap transformer. This is an input waveform. This is output waveform. Let me show you output waveform after smoothing from this bridge rectifier. I will run this program without capacitor. Let me connect this capacitor which is parallel to this R load. Then I will run this program. You can see this output. But don't worry about this initial position. You can be neglected. You can ignore this initial position, and we can consider output waveform as a straight line. Then what is the difference of this waveform than previous half wave rectification? Then keep in mind this ripple voltage. This ripple voltage is less than before. In full wave rectifications, output ripple voltage is less than half wave rectification output voltage. Students, can you explain these observations? If you see this clearly, this arrangement also same to that bridge rectifier. In previous case, you saw how to arrange a bridge rectifier within 4 diodes. But in this screen, you can see another arrangement, but it is same to previous method. Actually, I have used for LEDs. You know, LEDs are another type of diodes. Then I use it because of then I can explain easily. Let me explain this. I will pause this circuit. You know, alternator is changing their voltage, positive and negative. Its positive and negative side is changing. Then I will consider one instance. In this time, upper side is positive, lower side is negative. Then current flowing in this path. That's why in the first diode is in forward bias condition, as well as this diode is in forward bias condition. other couple of diodes in reverse bias condition. Then these two diodes, two LEDs, allow to flow current. Then keep in mind current flowing in this direction through this motor. Let me run again. Let's pause this circuit in this situation. Then the voltage should be like this. Then current flowing in this path. In this time, that previous diodes is in reverse bias condition, but this couple of diodes, couple of LEDs in forward bias condition. In this time, current flowing into same direction. Now you can confirm a function of bridge rectifier circuit. Now let's talk about average output voltage from this two type of rectification. We can take average output voltage from full wave rectification using this relationship. It is 0.637 into peak voltage. What is the average output voltage from half wave rectification? It is 0.318 into peak voltage. Students, I want to tell you interesting matter. In half wave rectification was removed part of wave from that alternating current wave and reduce average output voltage. It was half. So can you remove any part of that current wave? Actually it can. But it must be used special type of switching devices such as power transistors and devices of thyristors family. Then you can remove any part of that current wave and can be controlled output voltage as you like. This type of power supply known as SMPS. SMPS means switch in mode power supply. If you check alt circuit, can be find huge transformers. It had to be used huge transformers to produce large ampere or large current. Then circuits were bulky and high weight. But now you can use SMPS to produce that high current. SMPS, a lightweight circuit. You will find in phone charger, laptop or other modern circuits. But I must warn you, don't repair SMPS circuits without good knowledge about it, such hot area and cold area in that circuits. Okay, we will meet again with another good lessons. Thank you.